In Chapter 7, we're going to be looking at functions and their graphs. What's really nice about Math 100 is each of the chapters sort of stands on its own. You don't need one chapter to understand the next chapter. So in this Chapter 7, it really doesn't have anything to do with Chapter 3. And then we'll move on from Chapter 7 to Chapter 8, which is personal finance. Very different from Chapter 7. Then we'll move on to Chapter 11, which is probabilities. Again, very different from the other chapters. And then we'll end up with statistics. So let's look at Chapter 7. In 7.1, we're going to look at functions and their graphs. The first thing we want to do is review our rectangular coordinate system. So that would be this graph where we have an x-axis, and that would be a horizontal axis, and we have our y-axis, which would be the vertical axis. The coordinate system is made up of 4 quadrants. So the first quadrant, and I'm just going to use a Q and put in a Roman numeral 1 for quadrant 1. So the first quadrant would be where the x and the y values are positive, and then we're going to move counterclockwise to quadrant 2. And in quadrant 2, your x values are going to be the negative, but the y values are positive. Quadrant 3, both x and y values are negative. And then quadrant 4. In quadrant 4, the x values are positive, but the y values are negative. Now, points that are actually on the x or y axis are not in a quadrant. The point here, the 0, 0, that's our origin. It's where we begin when we graph. Let's look at example 1 and review how to plot points. Now, oftentimes in this textbook, they'll give the point a name. If you notice, the first point to graph is A, which is the point -1, +4. So when we graph, it's always in alphabetical order, X first, then Y. So X, a value of -1, means we're going to go in the negative direction. So positive would be to the right, negative would be to the left. So we go to a -1 on the x-axis, and then a +4 for the y means we're going to go up 4. So positive y is up, negative y is down. So from the -1 to the x, I'm going to go 1, 2, 3, +4 in the y direction. And that would be my point. So we always want to label our points. In this case, you could label it as -1, 4, or you could just put A, since it has a name, or you could do both. Let's try another one. Point B is 3, -2, so we go a +3, 1, 2, 3 on the x, and then we go down 2 on the y because it's a -2. And instead of writing the ordered pair 3, -2, I'm just going to label this B. C is 5, 0, so 5, 1, 2, 3, 4, 5 on the x, positive, but 0 movement on the y. So this point is actually on the x-axis. It's not in a quadrant. And this would be the point C. And then our last point D is 0, -5. So 0 movement in the x direction, left or right, but we're going to go down 1, 2, 3, 4, 5 to a -5. And this would be our D point, or the point 0, -5. So let's move on from our coordinate system. One way that we can graph equations is by just plotting points. So we're going to look at this example. And oftentimes in this section, you'll find a lot of application problems. Example 2, we have a toll bridge. Now in Hawaii, we don't have toll bridges. But in the mainland, oftentimes they'll have a toll bridge. It costs $1.50 to use the bridge. If you use the bridge X times in a month, the monthly cost Y is the equation Y equal to 1.5X. So remember, X is how many times you use the bridge. Y is the monthly cost. So you see if X is 0, your monthly cost would be 0. Now, if you buy a $4 coupon book, the toll is reduced to $1 each time you use it, but you got to buy the book. So the monthly cost, if we were to make an equation, and you're still letting your X be the amount of times in a month that you use the bridge, is going to be Y equal to 4 plus X. And where this equation comes from is, Y is your monthly cost. You have to pay $4 for the coupon book, and then you're going to add in $1, so that's 1 times X is the amount of times you use the bridge, so it's $1 times X. So we have these two equations. One would be your monthly cost without the coupon book. One would be your monthly cost with the coupon book. In the table below, we're going to figure out the values for different X values. And something in your MyLab that you have to be careful with is oftentimes they'll give you X values to put in, or maybe they'll say use integers from maybe -2 to +2. So just be careful about how you read the problem and what they're asking you to find. So in this particular case, I'm saying that the X values are going to be 0, 2, 4, 6, 8, and 10. And in my table, I want to make a table of values for each equation. So the first one would be without the coupon book. So if X is 0, my Y value is going to be equal to 1.5 times 0, which is simply 0. That gives me the ordered pair 0, 0 that I'll be graphing on the next page. If X is 2, my Y value is 1.5 times 2, which would be 3. And this is the point 2, 3. If X is equal to 4, then 1.5 times 4 is 6. We have the point 4, 6. And if X is equal to 6, then it's going to be equal to 9. And here you could feel free to use a calculator. So this would be the point 6, 9. And if we keep doing that, when X is 8, Y would be 12. If X is 10, Y is 15. So what this means is, and look at the 10. If X is 10, that means you use the bridge 10 times, and your monthly cost is your Y value, which is 15. So if you use the bridge 10 times, your monthly cost is $15. I'm going to use a different color. Maybe I'll use red. With the coupon book. With the coupon book, we're going to look at the same X values. So if X is 0, Y is equal to 4 plus 0, which is 4. So even if you use the bridge 0 times, you still have a monthly cost of $4 because you bought the coupon book. If you use the bridge twice, that means X is equal to 2. So the Y value is equal to 6. Use the bridge twice, your monthly cost is $6. And then 4 would give you 8. And so on. So we should have 6, 10, 8, 12, and 10, 14. So we have these two equations. The next thing we're going to do is we're going to graph these ordered pairs. They'll turn out to be lines. And then we'll connect the dots. Okay. So I'll keep with the color. My first point was 0, 0. And that would be without the coupon book. So without the coupon book, I had the point 0, 0, then I had the point 2, 3, so maybe almost to the 4, right? And then I had 4, 6, We had 6, 9, so that would be a little more than 8. 8, 12, 10, comma, 15, so right below the 16. Okay, and it looks like it's in a line. Now, I'm hand graphing this, so forgive my line. It might be a little bit crooked, but we can assume that it's going to keep going. I'm actually going to label this line as y equal to 1.5x. And then I'll use red to graph the other points. Remember, the first point was 0, comma 4. Also notice that this graph only has the first quadrant. If I were to continue on and make this graph larger, I would have the x-axis and the y-axis. However, since all my values are positive or 0, I actually don't need all the other quadrants. And oftentimes you'll find that when you're doing these application problems, you don't need the whole coordinate system. You maybe just need the first quadrant. So our next point would be 2, comma 6. And the next one is 4, comma 8. We have 6, comma 10, 8, 12, 10, 14. Okay, so again, this is kind of a straight line, looks like a straight line, but I am hand graphing it, so it's going to be a little bit weird. So y equal to 4 plus x would be the second equation. Notice that these equations, they actually intersect and share this point in common, which would be the point 8, 12. So part C says, what is the point of intersection? The point of intersection would be the point in parentheses 8, comma 12. So what does this mean? Well, in this particular problem, that means when you use the toll bridge 8 times, the monthly cost is the same. So the monthly cost here is $12. So the monthly cost of $12 is the same. So it doesn't matter if you buy the coupon book or not. Notice that the lower blue line, and that would be using the bridge from 0 to 8 times. Notice the blue line is lower. That means that the monthly cost is lower. After 8 times, the red line is lower, which means the monthly cost is lower. So it looks like if you're going to use the toll bridge less than 8 times, you should not buy the coupon book. If you're going to use the bridge more than 8 times, you should buy the coupon book to save money. All right, the next thing we want to talk about, so we're kind of jumping around in this section, is what a function is. Now, I'm not sure if you've seen function notation before, but oftentimes instead of writing y in our equation, we'll replace the y value with this f with parentheses x. How that reads is, this is f of x. It is not f times x. The parentheses do not indicate multiplication. What that's telling you when you use the letter f, or we'll find that you can use other letters like g or h and so on, is that it's telling us that this is not just an equation, this is a function. So a function is a special equation that has special properties, and the properties are below. For every xy, the x value has exactly one y value. So that means if you put an x value into your function, you'll get exactly one y value back. And that's the property of a function. In example 3, we're going to use this function notation. So if I had to find f of 6, what that means is in my function that I'm given, and this is the function that I'm given, 4x plus 5, it tells me it's just a substitution. It says wherever you see this x, you're going to replace it with 6. So it's just a substitution where you substitute the 6 for the x. So it's going to be 4 times 6 plus 5. So 4 times 6, that's 24, plus 5 is 29. So just be careful of your order of operations. So we should have gotten 29. Let's try another one. In C, and I took out B because there was just too many examples. In part C, we have h of -4. And that tells me that in my function, and this time there's no x value, we're using the variable r. But what this says is h of r is equal to r squared minus 7r plus 2. It tells me wherever I see r, I replace r with -4. So be careful with negatives. H of -4 is going to be -4 squared, but it's in parentheses. Since the -4 is the r value, it's included. So you're squaring -4, it's going to turn into a positive 16. If you don't have the parentheses on it, you might make the error of making it a -16. So this is -7 times -4 plus 2. Positive 16, negative times negative is positive, so that's going to be a plus 28 plus 2. And then if we add all that up, it should be 46. So please be careful with your order of operations. So now we're going to use the function notation instead of an equation, like we did in our toll bridge example. Example 4, we have this function. So we're given f of x is equal to 0.0875x squared minus 0.4x plus 66.6. This is the function we're given. Now, you definitely want to use a calculator here. So what this function is modeling is the car's stopping distance. So f of x. Now remember, f of x is simply the y value. So this f of x, which is our y value, is the stopping distance on dry pavement when you're traveling, and here the x value is your miles per hour. So x is your speed, your miles per hour. Y is your stopping distance. So clearly the faster you go, the larger your y value, the larger stopping distance you'll need. The slower you go, the less stopping distance you'll need. If you look at this graph represents the equation, which is the stopping distance of cars on dry pavement. So look at the first value here. This graph starts at 20. Remember, that's our x values, that's our speed in miles per hour. So at 20 miles per hour, if you're traveling 20 miles per hour, you need a stopping distance of 100, and here the units are feet. So you would need at least 100 feet to stop. And that's how you read this graph. In question A, it says use the graph to estimate the car's stopping distance at 40 miles per hour. So here we're just using the graph, we're not using the equation. So if I look at the 40 miles per hour, it's going to correspond to this point, which looks like it's just under 200. So maybe 199 would be an okay estimation. It's just an estimation based on the graph. So I'm going to say probably 199 feet. And we're rounding to the nearest 10 feet. Ooh, to the nearest 10 feet, now that would be 200, right? Because I go one up, so 200 feet. And I did that so that you could see that you have to be really careful about reading directions. Oftentimes in my lab, especially when we start using calculators now, they'll ask you to round things to the nearest foot or to the nearest whole number or to one decimal place. So just make sure that you're reading the directions correctly. In part B, we're going to use the function. So if we use the function, the 40 miles per hour, that's the x value that we're going to put in our function. So the stopping distance would be f of 40. That will be equal to 0.0875 times 40 squared minus 0.4 times 40 plus 66.6. So when I put this in my calculator, I get 190.6, and this is the units for feet. So notice looking at the graph, it's a little bit misleading. When I put that value in the actual function, the 190.6 feet, that's my actual stopping distance if I'm traveling 40 miles per hour. So we looked at graphs and we looked at equations. We found ordered pairs. We did our graphs. We're just going to do a few more. So in example 5, we're going to graph these two equations. The first equation is f of x equal to 2x. So this is in function notation. The second one is g of x equal to 2x minus 3. So we're going to do what we did in our first example. We're going to come up with our ordered pairs to graph, and then we're going to connect the dots. So f of x is equal to 2x. And also notice that the directions say select integers for x from -2, +2. So the integers would be -2, -1, 0, 1, 2. When I put -2 into my function, I have f, oops, always do that. Forget to change the thickness of my line. So I have f of the x value is -2. That's going to be equal to 2 times -2, which is equal to -4. So this first ordered pair is going to be an x value of -2 and f of x value of -4. But remember, f of x is y, so you can always replace, well, that was a loud rooster, f of x with y. If we put in -1, f of -1 is equal to 2 times -1, which would be equal to -2, and I have the point -1, -2. If I put in 0, f of 0 is 2 times 0, which is simply 0, and I have the point 0, 0. So continuing on, I should get 1, 2, and 2, 4. Let's look at the function g of x. So g of x is equal to 2x minus 3. If I put in -2, then g of -2 is equal to 2 times -2 minus 3. So that's going to be -4 minus 3, which would turn into a -7. The ordered pair is -2, -7. And then g of -1 is equal to 2 times -1 minus 3. So that's -2 minus 3 would be a -5. And I have -1, -5. G of 0 is equal to 2 times 0 minus 3, which is -3. 0, -3 would be that point. Again, keep going, and I have 1, -1, 2, 1. So we'll go ahead and graph these two equations on their coordinate system. We'll start with F, and I'll use blue to be consistent. We have x value of -2, a y value of -4, so down 1, 2, 3, 4. And I have a -1, -2, 0, 0, 1, 2, 2, 4. I have this blue line. And since it was given the name of F, I'm going to use that letter. So something I did want to point out is notice that we were graphing two functions in the same problem. So we couldn't call them both f of x. We had to give them a different name. So we chose to call one f of x and one g of x so that it's clear which one we're actually graphing. Let's look at G. It's going to go through -2, -7. So -2, this only goes to -6. So -7 is going to be down below that graph somewhere, which is fine. We'll go to the next point, which is -1, -5. And the next point, which is 0, -1, 2, 3. And then 1, -1, 2, +1. When I graph this next line, I could see that my graph G and my graph F, they're never going to intersect. So I wanted to do this example to remind you that graphs that don't intersect are parallel. At the top, we were told to graph the functions. We were told which integers to select for x. And then we're also asked the following. How is the graph of G related to the graph of F? How they're related is they're parallel. So G and F are parallel. What's interesting about parallel lines is they have the same slant or the same slope. And later on in another section, we're going to be talking about slope. But first of all, let's go on to look at what happens if we have graphs, but we don't have an equation. So far, we have looked at graphs and we were given function notation so that we knew that they were functions. But if you have a graph, how can you tell if your graph represents a function? Well, we use the vertical line test. And the vertical line test says if every vertical line passes through at most one point, then it is a function. If you can find even one vertical line that passes through two or more points on your graph, then it's not a function. So in graph 1, is this a function? No, it's not a function. I can draw a vertical line that passes through 2 points. So a function, at most 1 point. Not a function, 2 or more points. Okay? So the question is it a function? No, this is not a function. Remember what a function says. It says for every x value, and I'll have some x value here. For every x value, you get exactly one y value. But notice for this particular x value, I get two y values, two different y values. So it's not a function. So this is all the vertical line test says. Look at the picture. If you can draw a vertical line that passes through two or more points, it's not a function. So in graph 2, notice that it doesn't really matter where I draw my vertical line. It passes through at most 1 point. So this means for every one of these x values, I have exactly one y value. Yes, this is a function. It passes the vertical line test. In graph 3, this is a function. No matter where I draw a vertical line, it passes through at most one point. So yes, this is a function. And then in graph 4, also a function. Doesn't matter where I draw my vertical line, it passes through at most one point. Let's do one last example in this section. And these examples, I didn't make up the numbers. They're actually real figures. Example 7 says when a person receives a drug injected into the muscle, the concentration of the drug in blood, measured in milligrams per 100 milliliters, depends on the time elapsed since the injection. And the time here is measured in hours. So here our X value is going to be the hours after injection. Y is going to be the drug concentration. So how much drug is in your bloodstream. And here this graph, if you look at 0, 0, that first point, that means 0 hours after the injection. So you haven't even been injected yet. And there's 0 amount of drug in your system, which makes sense. Part A says, during which period of time is the concentration increasing? So the concentration is increasing, and maybe I'll highlight this, if the graph is going up. If a graph is going up, that's where the Y value, it's getting larger and larger and larger, and the Y value is your drug concentration. So from 0 to, it looks like about 3 hours. So from 0 to 3 hours after injection, right? If I was just to look at the graph. Part B says, during which period of time is the concentration decreasing? So the concentration is decreasing if the graph is going down. And the graph is going down from 3 hours until it looks like it just stops at 13. So you could say after 3 hours, or specifically from 3 to 13 hours after injection. The way you say it is up to you, right? There's many ways to write the answer. From 3 to 13 hours after injection. That'll work. Okay, so part C says, what is the drug's maximum concentration and when does this occur? It looks like, if I was to go back to the graph, it looks like it reaches maximum, so that's the highest point on your graph, maximum concentration at 3 hours. So it looks like it's at 0.05. So the drug's maximum concentration would be 0.05, and it was measured in milligrams per milliliters. And when it occurs, 3 hours after injection. So you could write out milligrams per milliliters. If you're not aware of how to abbreviate those. So I'm going to put maximum concentration is 0.05, and if it's milligrams per milliliters per 100 milliliters, I could do mg over 100 ml, or I could just write it out if I'm not sure of the abbreviation. And it's per 100. So ml would be milliliters, but again, if you're not sure, then you just write it out. And that would be at 3 hours after injection. What happens by the end of 13 hours? No drugs. So it looks like after 13 hours, it looks like that's where the graph stops when we look back at the graph. So it appears by the graph that after 13 hours, the concentration of drug in the blood is 0. I'm just going to be lazy and write no drugs in blood. Okay. Explain why this graph describes y as a function of x. Why is this graph a function? Well, if you look at this graph, it passes the vertical line test. So the justification here is it passes the vertical line test. And that's it for this section. The goal of this section was just to look at some basic graphing, to review function notation, graphically what is a function by vertical line test, and then pretty much just reviewing the coordinate system. Okay, so the next section we'll look at in chapter 7 is 7.2, and then we're going to jump all the way to 7.6. So we're not going to cover all of chapter 7, just 3 sections.